Digital audio has significantly lower bandwidth requirements than video. Digital audio, however, has its own unique properties. The main problem here is most of the devices they produce audio in the form of analog. The analog audio signal is usually sampled at a fixed rate, for example, 8,000 samples per second. Once we try to sample, so collecting samples means when you have a digital audio, when you have an audio or speech of someone for let us say uh, 5 minutes or 10 minutes, we see the variations in his voice in terms of pitch, in terms of modulation, in terms of many other properties of the video. So what we try to do is we collect around 8,000 samples of uh, such audio sample per second. Every second we just try to take around 8,000 variations in the audio, and then we sample it and keep. So each of these samples is then rounded off to some finite number of values. Now this operation is referred to as quantization. So if 8,000 samples do not have not many variations, we can limit these variations to a certain number of discrete values. Now the number of finite values are called quantization values. Usually we just quantization value, we just express it as a power of 2. Now suppose let us say we have rounded off these 8,000 lab values to 8,000 samples to some 256 quantization values. Each of the quantization value is usually represented by a fixed number of bits. For example, if there are 256 quantization values, then each value and hence each audio sample is represented by 1 byte. Now the bit representations of all samples are then concatenated together to form the digital representation of a signal. It's like 8,000 samples. Out of these, we just took around 256 quantized values and associated every quantized value with certain bit representation. Let us say you have a peak audio or the audio sample with a very high peak pitch. Now this one is represented by certain bit values. Let us say all ones of the 1 byte that we took. Then the slightly lower pitch value was represented by maybe all ones and 1 0. Like that, we just associate some kind of bit representation to every variation that occurs in these samples. So then, in order to represent 8,000 samples, we require around each one represented by 8 bits. The total signal is now represented by 64,000 bits. That is how we convert every analog signal into a digital signal. Digital signal is associating some symbol or some kind of code to every sample. So samples here is we are talking about 8,000 different samples. 8,000 different samples, and we coded or encoded every sample with some code value. Next time, say, whenever we are talking about an audio signal like that, we are going to represent every variation with some code. So how does the computer understand when we decode? When we know that when we come across this code, I need to understand the parameters of the audio are going to be a very high pitch, uh, average modulation, and whatever bass you have or whatever other properties that you have to the audio. So that is represented as one bit value. The other variation is represented as another bit value, and accordingly it converts and selects such a bit values which it has already stored in its library. So for playback through audio speakers, the digital signal, such a digital signal which we have concatenated using 8,000 samples, each represented by 8 bits. A concatenated sample in our case was 64,000 bits per second. Now this one is again converted back into original audio by decoding it. So the code here was 8 bits for every sample. See, or the decoded analog signal. So now since we have quantized the values, we have approximated the audio signal, and not every feature of the audio has been captured and then stored. The decoded audio signal might not be same as the original signal. It's only an approximation of the original signal. So by increasing the, so now how do you improve the quality of the audio signal? We try to improve the sampling rate. Instead of 8,000 samples, now suppose in a second we just take 64,000 samples, or maybe 16,000 or 32,000 or 64,000 samples, then we try to record more variation. And if you associate more bits to every sample, then we are able to record or encode many more variations in your audio signal. Sometimes we try to store even the finest variations in your audio signal. That way, the kind of decoded signal becomes better and better near to the original signal. Now, this kind of technique in which we try to convert analog audio into the digital audio is called as pulse code modulation. Speech encoding, usually the standard technique the pulse code modulation uses is its sampling rate. The sampling rate happens to be very, very important, which is around 8,000 samples per second, 8 bits per second, 8 bits per second. Bits per sample, resulting in a rate of 64 kilobits per second. The audio compact disc that we use is, usually we all buy audio compact bits. This is the one which uses the pulse code modulation, and as far as high quality audios are concerned, their sampling rate is 44,100 samples per second, with every sample represented by 16 bits. That means it gives a rate of 705.6 kilobits per second for mono, and if you want a stereo effect, they are going to use 1.411 Mbps per stereo. Now, pulse code modulation encoded speech and music, however, are rarely used in the world of internet. Now, if you are going to use such a high rate encoded audio samples in internet, we know that internet is all about communicating and sending the digital audio signals from one source to another destination. Now, if you are going to encode it at a very high rate, it's very difficult to transport the audio signals. So instead, as like in video compression techniques, we also use what is called as audio compression techniques. The main idea behind the audio compression techniques is reduce the bit rate of the stream. Now, human speech can be compressed to less than 10 kilobits per second, and still we know that it is intelligible. Now, most of our video conference calls or WhatsApp calls, everything is pretty intelligible. ऐसा तो नहीं लगता है कि हम लोग हर एक शब्द जो है नहीं सुन पा रहा है, and we are not able to grasp the inner meaning behind every speech. It is intelligible. Now, at the end of the day, every video call, it only needs to be intelligible to the people who are attending to the call. We don't want any more quality than that. I know that if you listen to any stereo music or any music over the CD, it's so clear and nice that हर एक शब्द and हर एक word के बीच का difference very clearly सुनाई देता है. When it comes to speech-based talking or any audio call, we don't want any high quality like that. We only want a transportable quality. So therefore we settle down with 10 kilobits per second. A popular compression technique which does so is called as MPEG. Usually MPEG has been olden days ways of compressing the technique. Now today's most famous audio compression technique is MPEG layer 3. So in a short form it is called as MP3. MP3 encoders can compress to many different rates. I know MP3 may we are able to get different rates of audio compression. So one famous rate is 128 kilobits per second is the most common encoding rate and produces a very little sound degradation. Remember, if you go for a very low rate, the sound can be degraded to an extent that we can't even, it can't be audible. A related standard is advanced audio coding technique, now which has been popularized by Apple. Most of the Apple Talk, Google Talk, they have their own audio compression techniques. What we are trying to do whenever we try to capture our sound is we are not the one who is selecting the audio compression algorithm. Now, most of these professional applications, they have their own audio compression ways, and what is the standard rate at which they are going to transport the audio is something professional to these applications. Apple has advanced audio coding technique. As with video, multiple versions of pre-recorded audio is already there. Again, we talk about what is called as adaptable audio stream, like in adaptable video coding rate. So depending on the bandwidth that is available and depending on how much traffic the internet has, we try to adapt the corresponding audio compression rate, which is